Welcome to The Explainer. Today, we're diving into some pretty surprising science, all based on the book Nature Wants Us to Be Fat. We're going to explore why we gain weight, and the answer might not be what you think at all. So let's start with a question that, so many of us have asked ourselves, right? You work so hard, you lose the weight, but then it just creeps right back on. It's this incredibly frustrating cycle. Today, we're looking at a biological answer that could completely change how you see that struggle. The book throws out this really radical idea that our bodies are actually wired to gain weight. It argues that, yeah, we blame our habits, we blame our modern lifestyle, but the real root cause is much, much deeper. It's written into our DNA, a relic of our evolutionary past. To really get this, we first need to explore a fundamental paradox about fat. And it's a concept that pretty much turns our whole modern view of health right on its head. Okay, so for us, fat has become public enemy number one. We connect it to disease, to poor health, the whole thing. But in the animal kingdom, fat is a superpower. Seriously, it is the ultimate survival tool. It provides the energy for these long migrations, it's insulation against the cold. It's a total 180 from how we think. See, in nature, survival isn't always about being the fittest. A lot of the time, it's about being the fattest. And this paradox is perfectly illustrated by the true stories of two very different men who went on these extreme fasts. It's a really stark comparison that shows you what body fat is really for. On one side, you have Mahatma Gandhi, super lean, almost no fat reserves. A protest fast of just 21 days brought him to the absolute brink of death. Then, on the other side, you have Angus Barbieri. He was severely obese, and he safely fasted, under a doctor's watch, for an unbelievable 382 days. He lived off his own body's fat stores and lost 275 pounds. So what was the difference? Barbieri had a massive fuel tank. Gandhi was running on fumes. So what this tells us is that fat isn't the villain we've made it out to be. At its core, it's our body's emergency fuel tank. It's a brilliant evolutionary tool that was designed to get us through times of scarcity. Okay, so fat is a fuel tank. What's telling the body to fill it up? Well, this brings us to the book's central concept, a kind of biological master controller for storing fat. It's called the survival switch, and you can think of it like an ancient software program that's just running in the background of your biology. When it gets activated by threats, like a famine is coming, or it's time to hibernate or go on a long migration, it tells the body, okay, time to store fat, slow down the metabolism, and even become a little bit insulin resistant to save that precious glucose for the brain. And here is the big problem for us today. In a world with endless food, that switch gets flipped to on, and it just gets stuck there. Our biology is getting these constant false alarms to get ready for a crisis that, well, it never actually shows up. The book puts our modern dilemma perfectly. It says we're trapped, perpetually preparing for a brutal winter that, thanks to grocery stores and delivery apps, just never arrives. So the million-dollar question is, what's the primary trigger that keeps flipping this switch on? The answer might really surprise you. It's not fat, and it's not just about the total number of calories. The book points the finger at one main culprit, fructose. And as this diagram shows, fructose is metabolized way differently from other sugars. It sets off this unique alarm pathway, one that basically screams at your body to store fat, no matter how many calories you've actually eaten. So how does it do this? Let's just walk through the steps. It's like a chain reaction. First, fructose makes a cell burn through its immediate energy source. It's called ATP, really fast. This sudden energy drop creates a false alarm, a panic signal of starvation inside the cell. Then, that process creates a byproduct, uric acid, which in turn puts stress on the cell's power plants, the mitochondria. And the end result? Bam! The survival switch flips on, and your body starts storing fat right then and there. This diagram really shows you the full domino effect. Fructose metabolism is essentially hijacking our biology. And as you can see, it's not just leading to fat accumulation, it's also making us hungrier and causing insulin resistance. It's all part of that ancient survival response. But the story gets even more complicated. It turns out it's not just about the fructose we eat in sugar or drink in fruit juice. There are other hidden triggers too. And the research reveals this crucial plot twist. Our bodies can make their own fructose. Yeah. This means we don't even have to eat sugar directly to turn on that fat storing switch. So, what triggers this internal production? The book points to a few culprits that are pretty common in our modern diets. High glycemic carbs like bread and potatoes spike our blood glucose, and the body can convert that into fructose. High salt foods, they can cause mild dehydration, which also turns on this pathway. And get this, even umami-rich foods like red meat can feed into the very same process. This diagram just brings it all together. You've got 4 different roads: sugar, high glycemic carbs, even salty foods, but they all lead to one destination: activating that fructose pathway and flipping the survival switch. The book really presents this as a kind of unified theory for all our modern metabolic problems. And when you look at this historical data, you can see this powerful correlation. I mean, the staggering rise in sugar consumption over the last few hundred years lines up perfectly with the rise of our modern obesity and diabetes epidemics. We didn't just stumble into this problem, we sweetened our way right into it. So this all sounds pretty daunting, right? We're fighting an ancient biological program. So how in the world can we possibly regain control and tame this switch? Well, the book suggests several really clear strategies. And notice, they aren't about just counting calories. They're about avoiding the triggers. So that means reducing added sugars, especially the liquid ones like soda, which are the most powerful activators. It means limiting those high glycemic carbs and high salt processed foods, staying hydrated with plain water to avoid that dehydration trigger. And interestingly, a modest dose of vitamin C might even help counteract some of the switch's effects. And just to put that sugar recommendation into perspective, think about this. The American Heart Association says men should have no more than 9 teaspoons of added sugar a day. A single 12-ounce can of soda can pack in 10 teaspoons. You blow past your entire daily limit in just one drink. This all leaves us with a final and pretty provocative thought. We've seen how this ancient switch controls our fat storage, but the book argues its influence goes way beyond that. If this switch can trigger things like foraging behavior and impulsivity to help our ancestors find food, could its chronic activation today be influencing not just our waistlines, but our behavior, our mood, and even our risk for conditions like ADHD and dementia? It's a powerful question about just how deep this biological programming really runs.